Hello, good morning. Let us now continue with our C-scores discussion of C-scores. We earlier learned how to get the area if we are given the C-scores itself using the C-table. This time, we will now learn how to get the C-scores, give and apply the C-scores into problems. So, remember that the area under the normal curve are given in terms of z-values or c-scores. Either c-score locates x within a sample or within a population. So, to solve for c-score for population, we have the given measurement minus the mean, population mean, divided by the population standard deviation. To solve for the c-score for sample data, we have the given measurement minus the sample mean divided by the sample standard deviation. So, knowing the formulas and knowing how to solve for c-score, we can now apply them into problems. Let us look at our first problem. The weights of students in a certain year level are normally distributed with a mean of 60 kilograms and a standard deviation of 3.5 kilograms. Find the probability that a student randomly selected from this group weighs less than 55 kilograms. Take note that we are looking for the probability that a student randomly selected will weigh less than 55 kilograms. Therefore, the given measurement or the given weight should be 55. 60 is our mean, and 3.5 is our standard deviation. Using the formula, we know that c-score can be solved by the given measurement, which is 55, minus the mean, 60, divided by the standard deviation, 3.5. This will give me negative 1.43. So from the table, we will use the table now to get the area if the c-score is negative 1.43. And the area from the table is equal to 0.0764. But we're looking for the weights below 55. So the weights below 55, the probability that the weight will be less than 55, or the probability that the c-score is less than negative 1.43. So from the table, we can allocate 0.0764. Our conclusion is therefore, since we're looking for the probability that the student weigh less than 55 kilogram, then it will be equal to 7.64%. Second problem. In a math test, the mean score is 45 and the standard deviation is 4. Assuming normality, what is the probability that the score picked at random will lie above score 50 and letter B below score 38? So, for the given problem, 45 is our mean. 4 is our standard deviation. For letter A, we're looking for the probability that the score will be above 50. For letter B, we're looking for the probability that the score will be below 38. So for letter A, let us now solve for the c-score. So 50 minus 45 all over 4. 45 is our mean, 4 is our standard deviation. Solving, our c-score will be equal to 1.25. Through the use of the z-table, we know that the area, if the c-score is 1.25, is equal to 0.8944. So the probability that the score is greater than 50 will be equal to 0.8944. This is now the area until the c-score is 1.25. But we're looking for the scores above. Then we have to subtract it from the value of the whole curve. The area of the whole curve is equal to 1 because we're looking for the scores above 50. Then we now subtract it from 1, giving us 0.1056. Therefore, our conclusion is the probability that the score pick up at random will be above, the random will be above score 50 is 10.56%. For letter B, we are now looking for scores below 38. Our mean is 45 and our standard deviation is 4. So 338 minus 45 all over 4 will give us a C-score of negative 1.75. From the Z-table, the area is equal to 0.0401. Since we're looking for the scores below 38, then the probability will now be 4.01. So let us, before we go to the next problem, let us take note of certain things. 1, if the score is above a given measurement, then we solve for the Z-score first. Second, we get the area from the Z-table. And then, if it is greater than or above, then we subtract it from 1. Now, if the score we're looking for is below a certain score, then again, we convert it to C-score and then get the area from the Z-table, and that will now be the area we're looking for. We simply just need to change the area into percent to better represent our probability. Example number 3. Scores on a scholarship aptitude exam are normally distributed with a mean of 72 and a standard deviation of 8. Mean is 72, standard deviation is 8. What is the probability that a randomly selected applicant will score above 60? Letter B, what is the probability that the randomly selected applicant will score between 68 and 84? So for letter A, we're looking for an applicant who will score above 60. For letter B, between 68 and 84. So the first thing we need to do is we now get the C-score. After getting the C-score, we get the area. If it's above, then we subtract it from 1. If we're simply looking for below, it will now be the probability. The area will be the probability. But if we're looking for scores between, then we have to make comparison. So let's look at letter A. What is the probability that a randomly selected applicant will score above 60? First thing we need to do is get the C-score. The C-score is the given measurement 60 minus the mean 72 divided by the standard deviation 8, giving us negative 1.5. From the Z-table, our area is 0.0668. But again, we're looking for score above 60. So this area of 0.0668 will have to be subtracted from 1, giving us 0.9332. Therefore, the probability that the applicant will score above 60 is 93.32%. Again, we subtract it from 1 because we're looking for scores above the given score. If we're looking for scores below, then whatever is the area will be now our required area, or we can simply change it to probability already. Now for letter B, we're looking for the probability that a randomly selected applicant will score between 68 and 84. So first, we change 68 to z-score. 68 minus 72 over 8 is negative 0.5. And the area for negative 0, if our z-score is negative 0.5, then our area will be 0.3085. Then we look for the z-score of 84. 84 minus 72 divided by 8 is 1.5. The area for 1.5 is 0.9332. We are looking for the probability that C is less than 1.5 but greater than negative 0.5. Therefore, we now subtract 0.9332 minus 0.3085 is equal to 0.6247. Therefore, the probability that the score of the applicant is between 68 and 84 is 62.47%. Okay, next. Fourth problem. It is known that the weights of mangoes harvested in a farm are normally distributed with a mean of 220 grams and a standard deviation of 25 grams. If a mango is selected at random, what is the probability that it weighs less than 210 grams? B. It weighs greater than 245 grams. C. Its weight lies between 180 and 250. So looking at the problem again, letter A, it weighs less than 210 grams. Because it's less than, then all we need to do is look for the C-score, get the area, and then change it to probability because it's now the probability or the area that we're looking for. For letter B, since we're looking for greater than, then we solve for the C-score, get the area from the Z table. Whatever is the area should be subtracted from 1. 1 is the sum, is the total area of the whole curve. Therefore, whatever is the difference will now be our probability, our area that we're looking for, which we can change again to probability. For letter C, we have to compare the C-scores and the areas of the two. Okay, let's do the solution. For letter A, it weighs less than 210 grams. So 210 minus, I'm here, 210 minus 220 over 25 is negative 0.4. The area for negative 0.4 is 0.3446. Therefore, since we're looking for the weights less than 210 grams, then the probability that the mangoes weigh less than 210 is 34.46 from here. This is the area. Since it's less than, we simply change this into probability or percent. Letter B, it weighs greater than 245. The C-score is computed by subtracting 245 minus 220 over 25 will give us 1. And the area for 1 is 0.8413. But since we're looking for greater than 245, greater than, then whatever this area is will have to be subtracted from 1. Subtracting, we're going to get 1 minus 0.8413 is equal to 0.1587. Therefore, the probability that the mangoes will weigh greater than 245 grams is 15.87%. For letter C, we're looking for probability that the mangoes weight will lie between 180 and 250 grams. So first, we solve for the C-score of 180. So 180 minus 210 over 25 is negative 1.6. Area for negative 1.6 is 0.0548. Second, we solve for the z-score of 250. 250 minus 220 over 25 is positive 1.2. From the z-table, the area for 1.2, if the z-score is 1.2, the area is 0.8849. But we're looking for the weights between, so we need to subtract 0.0548 from 0.8849. So the probability that the mango's weight will be between 180 and 250 grams is 0.8301 or 83.01%. Okay, before we go to the written output, what do we have to remember? We have to remember first, we now subtract the mean from the given measurement divided by the standard deviation. The first thing that we need to do is solve for the z-score. To solve for the z-score, we now subtract the mean from the given measurement and divide it by the standard deviation. After getting the z-score, we will get the area from the z-table. If it is less than, then whatever the area is the probability, which can also be expressed in percent. If we're looking for greater than or above the given measurement, then whatever is the area of the z-score will be subtracted from 1, the result of which, or the difference, will be the area or the probability that we're looking for. If we're looking for between two certain weights or certain scores, then we separately solve for the z-score of each. After getting the z-score, we now get the area of each, and then we subtract the smaller from the higher to get the area in between the given measurements. Okay, for a written output number 4, you're asked to solve the following problems. Okay, it is known that the number of calories burned after walking for 1 hour at the rate of 5 kilometers per hour is normally distributed with a mean of 300 calories and a standard deviation of 8 calories. You are to find the probability that a man who walks for 1 hour at the rate of 5 kilometers per hour will burn more than 280 calories. 280 is our given measurement, 300 is our mean, 8 is our standard deviation. For letter B, less than 295. Okay, again, if more, we subtract. The area we will get after getting the z-score will be subtracted from 1. If less, whatever is the area can be just turned into probability. It's also the probability. So let us repeat the procedure again. First thing we need to do is, for letter A and letter B individually, separately, we solve for the z-score. After solving for the z-score, we get the area from the z-table. If we're looking for more, we subtract that area from 1. Whatever is the difference is now the area we're looking for or the probability that we're looking for. We just need to change it to percent. If we're looking for less than, then again, we solve for the z-score, get the area from that z-table. Whatever is the area will be the area we're looking for, which will represent the probability, which we can also change into percentage. For number 2, the mean number of firecracker injuries reported in a certain hospital in Cavite, New Year's Eve is 300 with a standard deviation of 20. What is the probability that the following number of injuries are reported in a given hospital? More than 320. less than 280, and between 290 to 310. Okay, again, the mean number of commuters in MRT station Pasay from 2 to 3 p.m. is 400 with a standard deviation of 20. What is the probability that the following number of commuters come to the station during the given hour? More than 450, less than 370, between 380 to 420. Okay, if there is any problem or clarification, I will be waiting for your questions and clarification in my webmail. Please send your solution, take a picture of your solution, and send it to me. Good luck, guys.